Welcome. Let's just jump right into it. Today, we're unpacking an absolutely game-changing approach to production efficiency, the theory of constraints, or TOC. Developed by Eliyahu Goldratt back in the 1980s, this philosophy completely flips how we look at manufacturing. Look, the ultimate goal of any manufacturing business is simple: make money. But to actually maximize that profitability, you can't just run around putting out fires on your factory floor all day. You've got to treat the underlying illness. So in this explanation, we're going to figure out exactly how to diagnose that illness and, more importantly, how to cure it for good.
Have you ever fixed a machine, or maybe solved a massive scheduling issue on the floor, only for the exact same problem, or honestly a worse one, to pop up somewhere else just a week later? It's incredibly frustrating, right? It feels like you're playing an endless game of whack-a-mole. You invest all this time, money, and energy into an improvement, but then, at the end of the month, your overall output hasn't actually changed. So why does that happen? Well, it usually comes down to a fundamental misunderstanding of how systems actually work.
To really get Goldratt's core concept, I want you to picture a water pipe. A constraint is literally just the narrowest point of that pipe. You know, some parts are wide, some are narrow, but the total amount of water that actually flows out the end, that is determined solely by that narrowest section. You can widen the rest of the pipe all you want. You can polish it, you can upgrade it to the newest material, but if you don't widen that specific narrow bottleneck, your total flow isn't going to increase by a single drop. In your factory, that narrowest point is your system's constraint.
So, how do we find and fix it? Here is our roadmap for today. First, we'll uncover those hidden bottlenecks in production. Second, we'll learn to identify the root problems. Third, we'll use the evaporating cloud to find a solution. And finally, we'll walk through a 5-step improvement map.
Okay, Section 1, Hidden Bottlenecks in Production. Let's start treating your manufacturing system exactly like a patient presenting with a chronic illness.
When a patient walks into a clinic, they describe what hurts. But the pain isn't the disease, it's just a symptom. In the theory of constraints, we call these common manufacturing pain points undesirable effects, or UDEs. We're talking about things like low inventory turnover, incredibly high cycle times, excessive machine downtime, poor overall equipment effectiveness, high breakdown rates, and of course, skyrocketing overtime costs just to meet your basic orders. If you're a manager, you probably spend, 80% of your day fighting these exact issues? But here is the big paradigm shift. These are strictly surface-level symptoms. They're the patient's cough, not the infection itself.
Treating the symptom is literally like putting a Band-Aid on a severe infection. Sure, you might reduce overtime this week by pushing your workers a little harder, or you might temporarily fix a machine, but the underlying infection is still there. The system is inevitably going to generate new symptoms. To actually win here, we have to shift our focus to curing the disease. That means relentlessly hunting down and eliminating the root bottleneck that's secretly causing all of these undesirable effects in the first place.
Which brings us to Section 2, Identifying Root Problems. Now that we know we need to find the root cause, how do we actually do that amidst the daily chaos of a busy factory floor?
Well, the theory of constraints gives us a really brilliant thinking process tool for this, called the current reality tree. Think of it as a logical cause and effect map. You start at the top with all those nasty symptoms we just talked about. Then, you use simple if-then logic to work your way down. Like, if cycle times are high, then inventory turnover is low. You just keep mapping these connections downwards until you realize something amazing. All these separate branches of chaos actually stem from one single, solvable root trunk. It answers the absolute most important question in any business. What exactly needs to change?
But practically speaking, when you're out there on the floor, how do you locate that root constraint? First off, don't just rely on casual observation. You've got to look at the data. Analyze your workloads to see which machine is tasked with more than 100% of its available capacity. Walk the floor and physically look for where work in progress, or WIP, is accumulating. See a massive pile of unfinished parts? The station right after that pile is usually your bottleneck. Conduct rigorous cycle time analyses and check those capacity utilization rates. The machine that's running at 99 or 100% utilization while others sit around idle, that's your narrowest pipe.
Moving on to Section 3, the evaporating cloud solution. So, you've mapped your reality tree, analyzed the data, and found your root problem.
But what if solving that problem puts you in an impossible management dilemma? The evaporating cloud is a framework designed to handle exactly that, relying on pure structured logic. Often, a root problem exists because management is stuck between a rock and a hard place. This tool is designed to resolve the dramatic tension between two completely conflicting business needs, and it does it without forcing some weak compromise. Let's look at a real-world example from our research on a manufacturing firm so you can see exactly how this works in practice.
We start by establishing the primary goal. In this case, the ultimate goal that everyone in the company agrees on is to reduce unit production costs. Nobody's going to argue with this, right? The CEO wants it, the floor manager wants it, but how do we actually get there? Well, this is where the conflict begins.
Let's look at the first side of the conflict. To reduce unit costs, requirement A is that we absolutely must reduce machine breakdowns. Downtime is just incredibly expensive. And logically, to reduce those breakdowns, we naturally assume we must increase the number of maintenance staff. We need more mechanics on the floor to fix things faster. Makes perfect sense. But hold on, here is the opposing requirement. To reduce unit production costs, requirement B is that we absolutely must not increase our overall labor costs. And to keep those labor costs down, we must not hire more maintenance staff. Do you see the tension here? One side is demanding we hire, the other side is demanding we freeze hiring entirely. This is the root conflict that's paralyzing the factory. Now, most managers would just compromise here, maybe hire a part-time guy, and ultimately fail at both goals.
But the theory of constraints teaches us to evaporate the conflict by breaking the underlying assumption. The assumption here was that only new maintenance staff can reduce breakdowns. What if we totally shatter that? The solution, which TOC calls an injection, is to implement total productive maintenance, or TPM. You launch autonomous maintenance. You basically train your existing machine operators to handle basic daily upkeep, cleaning, and lubrication. By injecting these changes, you evaporate the conflict entirely. You drastically reduce breakdowns without hiring a single new maintenance worker. Both needs are met simultaneously. It's honestly a real game changer.
All right, Section 4, the 5-step improvement map. We know how to find the bottleneck, and we know how to resolve the conflicts preventing us from fixing it.
Now let's pull it all together into a concrete, repeatable master plan for continuous efficiency. These are Goldratt's famous 5 focusing steps, and this is your ultimate roadmap. Step 1, identify the constraint. Step 2, exploit it. Step 3, subordinate everything else. Step 4, elevate the constraint. And Step 5, repeat. Let's break down exactly what each of these means on the factory floor.
We've already talked about Step 1, identifying the constraint using your data. Step 2 is to exploit that constraint. This means before you run out and buy $1 million new machine, you absolutely must squeeze every single drop of potential out of the current bottleneck without spending a dime. Think about it. If a specific machine is the constraint, it should never ever stop running. No stopping for lunch breaks, it shouldn't be processing defective parts, and it definitely shouldn't sit idle waiting for materials. You've got to maximize its current capacity through sheer operational discipline. Okay, Step 3. This is often the hardest one for traditional managers to accept. Subordinate everything else. This means every non-constraint resource in the factory must slow down and march strictly to the beat of the bottleneck's drum. If a really fast machine feeds a slow bottleneck machine, that fast machine must be intentionally slowed down. If you don't do this, you're just going to build up a massive, wasteful mountain of inventory right in front of the bottleneck. That ties up your cash and hides quality issues. Efficiency at a non-constraint is literally a mirage. Once you have exploited the current capacity and fully synchronized the factory, only then do you move to Step 4, elevate the constraint. If this step is still the bottleneck limiting your entire company's profits, now is the time to open the checkbook. Now you buy that second machine, maybe run a third shift, hire more specialized personnel, or implement advanced lean tools like rapid setup techniques to drastically reduce changeover times. This is when you spend the capital to permanently break the bottleneck. But wait, you aren't done. Step 5 is the warning: prevent inertia and repeat. Because the moment you successfully elevate and break one constraint, congratulations, your system's flow just increased. But that water is going to instantly hit a new narrow point somewhere else down the pipe. A new constraint has just appeared. Management complacency, or inertia, is the ultimate enemy here. You must immediately go back to Step 1 and start the cycle all over again. Continuous improvement is an endless, highly profitable loop. As we wrap up this explainer, I really want you to remember this core philosophy from TOC. Every system has at least one constraint. A system's performance is limited by that constraint. Honestly, this isn't a problem to complain about, it's a massive opportunity. Because it means you don't have to fix everything in your business all at once. You just have to find the one right thing, the constraint, and focus all your energy there.
That is the true secret to scaling your profitability. So I'm going to leave you with this final provocative thought. Tomorrow morning, when you walk onto your factory floor or into your office, try to look past the symptoms. Look past the localized chaos. Ask yourself, where is the narrowest pipe in your system? Find it, exploit it, elevate it, and watch your entire organization's performance soar. Thanks for joining me on this explainer, and hey, happy bottleneck hunting!